Hi everyone. I am Suman Chaudhary. Currently, I am the master student in Department of Information and Computer in Taiwan Liu University of Technology, China. First of all, I would like to thank the organizers for allowing us to present our work in this conference. And the topic of our presentation is Ensemble deep learning method for COVID-19 detection via chest X-rays. So the first part is introduction. COVID coronavirus disease 2019 is a contagious disease caused by the severe acute respiratory syndrome coronavirus. It appeared at the end of the 2019 and has already spread globally, claiming millions of people's lives. Early diagnosis of COVID-19 can significantly increase the transmission rate and prevent the virus from spreading around. In this work, we present deep learning based method to detect COVID-19 from given X-ray images of patients. So here is our methodology. The data set we used was from this postgraduate challenge COVID-19 detection via chest X-rays. And here is the frequency of the images on the each set and on the each classes. And the first step was the data preprocessing, and on training set we applied 5 transformation. We downsample the image to 224 by 224, and we scale the intensity. We apply random rotation, random flipping, and random zooming. And on validation and tested, we simply downsample the image to 224 by 224, and we scale the intensity. And now our classification networks. First, we train the 3 state-of-the-art neural network model individually that can classify given X-ray into 3 classes: COVID, normal, and pneumonia. The first network is the efficient net model, and it was initialized with the weight trained with noisy student technique on the ImageNet dataset. The detail of the noisy student technique can be found in this paper. Self-training with noisy student improves ImageNet classification. And the second model was this squeeze and excitation range next model. And the third model was also the efficient net, but it was initialized with the weight trained with adversarial training technique on the ImageNet database. The detail of this adversarial training technique can be found on this paper. Adversarial examples improve image recognition. The efficient net model basically provides efficient way to balance the dimension of the width, the depth, and the resolution of the network. And the details of the efficient net can be found on this paper. Efficient net rethinking model scaling for convolution neural network. And the next model is the this squeeze and excitation ResNext, which includes the squeeze and excitation block in the ResNext model. This squeeze and excitation block basically consists of the 2 operation: squeeze operation and the excitation operation. For example, if this is the output in the any given layer, in squeeze operation we apply the global average pooling on each channel, and in excitation block we pass the averaged output through the multi-layer perceptron to obtain the weight for each channel. And finally we multiply this weight with the initial corresponding channel in initial output. And these squeeze and excitation block can be incorporated with any state of the art models. And finally we ensembled these models by simply averaging their output for each classes as shown in the figure. And now some experimental details. We use the Monai framework to augment the data, and PyTorch framework to design and train the neural network model. We said batch size was set to 64. We used cross entropy loss function and the Adam optimizer with the initial learning rate of 0.001 to optimize the learning process. And during training, If there was a continuous decrease in the validation accuracy up to 5 epoch, we initialize the model with the current best epoch and decrease the learning rate by a factor of 10, and we continue the training process. As you can see, and this is the result of our models on the validation and the test set. As you can see, Ensemble model outperforms all the single model in all the three metrics: accuracy, sensitivity, and specificity. So finally, in conclusion, our work demonstrated the potential of deep learning based method and importance of ensemble and transfer learning to detect the COVID-19 from the given chest X-ray image. Thank you.